Today's lesson is all about angles of a quadrilateral and using algebra and properties of quadrilaterals to find missing angles and variables. So let's get to some rules. The interior angles of a quadrilateral add up to 360 degrees. So remember how you found the missing angle of a triangle? You do the same thing here. Same concept. So what I would do is add 127 plus 88 plus 52. And that gives me 267. 360 minus 267 is 93 degrees. So the measure of angle X is 93 degrees. Very simple concept for you. Here, we're applying what we learned from the last lesson, applying what we know about diagonals of parallelograms. We know that they bisect each other. That means that AE is congruent to CE. So if we know that, CE is 6, and AE is 2x plus 2, there's our equation. 2x plus 2 equals 6. Subtract 2 from both sides. 2x equals 4, so x equals 2. Now you're using the properties to solve for variables. Now here, fill in the measures of the alternate interior angles. Measure of EAD. I'm going to highlight it so you can see which one it is. EAD. You've got to figure out what that measure is. I'm going to highlight it so that you can tell the match. Well, if you look, you can see ECB is 65 degrees. EAD, this one here, is an alternate interior angle, so its measure is also 65 degrees. Because parallel sides AB and DC are cut by transversal AC. So I'm just going to point this out to you. We're going to go, let's pretend this goes on forever. That goes on. And then you can see, there, I made them parallel lines and a transversal. So you can see what we're doing. Now you can see that angle EAD is an alternate interior angle with angle ECB. We're going to do another angle. Now we're going to find measure of angle EDA, which would be EDA. This angle. And this is where, wrong angle. The downside to me putting in so many colors is I lose track of things. Hang on a second. Whoops. Clean up my little messes. Put my line back. Put my highlighter back. All right, EDA, this way. Same concept with the alternate interior angles. Angle EBC is 44 degrees. So is EDA. Now I want What you can also do, I'm going to really tax your brains on this one. This isn't in there, but I want you to think about this. What is the measure of angle BEC? Well, you're going to apply some stuff here. That would be this angle. This is where you have to apply what you know about triangles. How many degrees are in a triangle? 180. So I'm going to go over here. 65 and 44 is 109 degrees. 180 minus 109 is 71. That angle is 71 degrees. So you can even figure that out based on what you know about triangles. We pull in information from all the 3 previous units when we start working on this. Now, you do have to remember, you will not always be working with alternate interior angles. You will need to use Unit 2 and triangle rules to solve, which is what we just did. We need a triangle rule to solve the measure of angle BEC. Now, if I asked you, you could give me the measure of all the other 3 interior angles, because you would know about linear pairs and you would know about vertical angles. All of this gets put together. Let's go to the next page. Okay, let's look at the parallelogram. And it is a parallelogram, so that means that, let's see, that means this side is congruent with this side is congruent with this side, because parallelograms, opposite sides are congruent. Let's find the value of x. The equation would be 2x equals 6, so x equals 3. That wasn't hard. I'm going to highlight again with angles. We want the measure of angle E, this big angle. That's what we want. In a parallelogram, do you remember that opposite angles are congruent? Property of a parallelogram. Well, if angle G is 98 degrees, the opposite angle is angle E. So that is 98 degrees. Get the little highlighter there. Now let's try the measure of angle EFH. That one. Well, that's intriguing. How on earth do I figure that out? That's a good question. Well, we're gonna do a little bit of triangle math here. It's a parallelogram. FH is a transversal, so that means angle EHF is 48 degrees because those 2 angles are congruent. And we already found this one, which was 98 degrees. How many degrees are in a triangle? Yes, 180. So let's figure this out. I'll do it over here. 98 plus 48 is 146. 180 minus 146 is 34. So, I should have done it in red, sorry guys. 34 degrees. 34 degrees. So we used properties of triangles. And again, properties of alternate interior angles, or rather, I'm sorry, properties of parallel lines cut by a transversal. Pulling in Unit 2. In geometry, each piece does not stand alone. They intermingle. Now, diagonals of rectangles have an additional property. We know they are congruent and they bisect each other because a rectangle is a parallelogram. Alrighty, let's do some labeling. Jn is 2x plus 6. I'm just going to write it right across. 2x plus 6. Ln is 5x minus 9. 5x minus 9. And we know that Jn is congruent to Ln because diagonals of rectangles are congruent and bisect each other. So we set up the equation this way. 2x plus 6 equals 5x minus 9. See, I'm just replacing. Let's do a little math. I'm going to subtract, let's see. I'm going to add 9 to both sides, so I have, follow my steps, 2x plus 15 equals 5x. Subtract 2x from both sides. And that means, next step, 15 equals 3x, divide by 3, x equals 5. Put it in here. So now I've got to find the measure of Jn. I substitute x. Jn is, let's do a different color. Jn is 2 times 5 plus 6, which is 16. Now let's go look at this problem again. Okay, what are we trying to find? We need to find Km. Well, Km is, highlighter time. This is Km. Now, we know, again, property of a rectangle, that JL is congruent to Km. And Jn is congruent to NL. Now think back to Unit 1 when we did the segment addition postulate. Small piece plus small piece equals bigger piece. Jn plus NL equals JL. So when we find the measure of Jn, which we did, we can multiply it by 2 to find JL. That'd be 32. If you're not sure of that, you can go ahead and substitute, where am I? Substitute 5 for x and find the measure of NL, or excuse me, Ln, and then you can add them together. And let's see, so JL is 32. Why does JL equal Km? Because diagonals are congruent. I'll put CONG from, I'll put the symbol. Because in a parallelogram, diagonals are congruent. How about Ln and Kn? You know what? Congruent. So I'm going to mark them now. This is congruent to this, is congruent to this, is congruent to this. All 4 small pieces are congruent. And the 2 pieces in each diagonal add up to the long piece. Whew, that's a lot of stuff. Let's go to a different color. Now we're going to find angle NKJ. This one. They want us to find this angle. We know, because they give us the information, NLK is 65 degrees. That's 65. Now again, properties of triangles. So, look at the triangle. We'll call the triangle KNL. It's isosceles. See, I marked the congruent pieces. If it's isosceles, that means that angle NKL is 65 degrees. Base angles of an isosceles triangle are congruent. So the measure of LKN is 65 degrees. Now the measure of each angle of a rectangle is 90 degrees. 90 minus 65 is 25 degrees. The measure of NKJ is 25 degrees. A lot of steps, but take your time with this. The material is not hard. You just have to get comfortable with your angles. You learned quite a bit of it, how to use them in Unit 3. Highlight, draw arrows, do everything you can to make sure you're finding the measure of the correct angle. Next page. We're going to do some more with rectangles and diagonals and lovely, lovely algebra. In a rectangle, as we said before, diagonals are congruent. Because it's a rectangle, I'm going to make some marks. Because I can do that. Why? Because it says in the rectangle below, I am told it is a rectangle. It is a given. And here's the information we're given. SU is 4x plus 2. RT is 5x minus 7. We know diagonals are congruent. So SU equals RT. Now I'm going to replace SU with the equation 4x plus 2 and RT with the equation 5x minus 7. All right, I'm going to add 7 to both sides. That gives me 4x plus 9 equals 5x. Subtract 4x from both sides and I get 9 equals x. So x equals 9. And we are supposed to find RV. Well, RV is 1/2 of RT. I know x is 9, so I need to find the measure of RT. So let's do that. 5 times 9 minus 7 is 45 minus 7 is 38. So RV is 1/2 of that. RV equals 19. Now we're going to find the next piece. Different color. We're supposed to find the measure of angle VUR. So I'm going to highlight it. VUR is this angle. Now let's put in what we already know. We know that SVT is 62 degrees. I'm sorry, yeah, angle SVT. So this one is 62 degrees. I'll put it there. Well, by the vertical angles property, angle UVR, or RVU, same thing, is also 62 degrees. Well, that's kind of cool. We can also see, and I'll make it more obvious, RVU, that triangle, is an isosceles triangle. See my two congruency markers in black? Which means these two angles I just did in yellow are congruent because they're base angles of an isosceles triangle. Well, how do we figure out their measure? You did this last unit. You take 180 and subtract 62. And you get 118 degrees. Now that's how many degrees are left after you have the measure of one angle. You divide that by 2 and you get 59 degrees. That one's 59 and this one's 59. So the measure of angle VUR is 59 degrees. Just using algebra. A little bit of information that you know, and you can figure out the rest. Next piece. Let's talk about the diagonals of a rhombus. Well, we know diagonals of a parallelogram bisect each other. Well, diagonals of a rhombus intersect at 90-degree angles. And they still bisect each other because it's a parallelogram. So diagonals of a rhombus also do something special. They bisect opposite angles. So let's do the first piece. Let's do the triangle, the rhombus on the left. We know they bisect opposite angles. Oh, and all opposite angles are congruent. That doesn't change. That's been a property. So if a diagonal of a rhombus bisects a diagonal, an angle, what's the measure of angle 4? Well, that'd be 44 degrees. And that means angle 2 is going to be 44 degrees, and so will angle no name. Here we go. In a rhombus, diagonals bisect opposite angles, and opposite angles are congruent. So the measure of angle 4, here we go, 44 degrees, and the measure of angle 2 is 44 degrees. Remember some of an interior triangle? Some of the angles, of an interior triangle is 180. So here we go. What is 44 plus 44? That's 88. I'm missing one angle here and one angle here. 180 minus 88 is 92 degrees. So angle 1 is 92 degrees, as is angle 3. And you can check by adding up all 3 angles in the triangle, and by adding up all the angles should add up to 360 degrees if you add all of them together. Now, remember what I said just a teeny bit ago about what diagonals do? They intersect at right angles. Make a right angle in the middle. So this, I can put that right there, which means I can find information with just a teeny bit. I can find all my information. Alrighty. If this angle is 36, the measure of this angle is going to be 36 because diagonals in a rhombus bisect angles, which means angle 1 is 36 and angle no name is 36. So let's put in what I know. I know angle 1 is 36 degrees. Now, how do I find the measure of angle 2? Well, I know this angle is 90 degrees, the one I just drew. 90 plus 36 is 126. 180 minus 126 is 54. That's a 5. Trust me, it's a 5. 54 degrees. So angle 2 is 54 degrees. So what's the measure of angle 4? 54 degrees. And the measure of angle 3 is 54 degrees. Because diagonals in a rhombus bisect opposite angles. Bisecting means cut in half. Alrighty, replay these notes as often as you need to, and we will talk about this in class.